All right, we're recording now. So, like I mentioned, we've gotten to the point where authentication is added in all the different levels. So we have our backend, which is forcing authentication on its routes. We've got the MQTT broker, which requires an authentication upon connection, be it the gateway or a different client. We have our Python client that actually provisions the vehicles at the moment. That we already had authentication added because provisioning was a auth required route. And we've added our user-based authentication to the vehicle simulation, right? We just went through the discussion on essentially you build this out, you get to a point where you have the vehicles would be able to authenticate themselves, right? And they would have their own credentials, and the cloud would go through a particular flow in order to get them authenticated. Now that we're at this point and the rest of the system working, we're going to add a little bit to our front end so that we can store our vehicle data inside of a context and access it from elsewhere within the app.
Just have a question. So at what stage the vehicle will get authenticated? Or
I'm sorry, can you repeat that?
yeah, at what stage the vehicle will be authenticated by itself? Like, you know, as soon as it's come from the manufacturing line, so it has to be bought by an owner to get authenticated, or where it's get authenticated.
Well, I would say that so that's going to be dictated by the firmware, right? That actually runs and controls the vehicle cloud connection. And I would say at what stage that would happen would be, it would be the moment that it tries to connect up to the cloud, right? That's like that's going to be a decision on the implementers, right? You could decide from the moment, like you said, that it exits the manufacturing line and you turn it on, right? It's going to try to go through its authentication flow at that point. But in order for that to happen, the credentials needed to be flashed or stored somewhere within the actual firmware, right? And so that's when you get into the entire provisioning process as to how do you actually get those credentials into the vehicle, right?
Yeah, sorry guys, my power went out actually. Fortunately, we got the recording, but we're gonna have to split the two recordings up here. But basically, what it really comes down to that manufacturing process. JC and I and the rest of the team, we spend a lot of time thinking through provisioning processes on how do you actually assign certificates, how do you assign credentials, and at what point is it safe to do that, and what the order in which you create, a record of something in the cloud, and do you do it before the actual physical thing is built, in this case a vehicle, or do you do it at the end of the manufacturing line? We typically will do it at the very beginning, even before the vehicle is built. And the reason you do it is because you can get a lot of information through the manufacturing process. And what you end up doing, the reason you want to push for that is there's so much data and so much learning and information that comes through that process, right? Because we're constantly doing things like the PLC and the robotics that are going in and actually putting those vehicles together. What they're doing is, you're getting a ton of data off of those. And what you can do is with that data, you can start looking at machine learning things down. And this is where your feature engineering comes in. So you can start looking at predictive things. So you can start identifying warranty issues on the line after it rolls off that line. And the thing is, you will have already cleaned your data, right? Because your data will already be associated with that VIN number that is starting on the line when that vehicle is going down. And it could just be a frame, it could literally be an engine block, it could be a bolt, right? But it starts somewhere. And as long as you have that VIN assigned from the very beginning, that ID, and it's in that system, all that data is being associated with it, so that in 2 years, when you're starting to see that, that 9-speed transmission start to break down, you can say, oh, well, it's because of these, 25,000 vehicles in this batch that came from whatever factory in Mexico or whatever. We're actually able to see this, and we're able to see that it's an inconsistency on the line with this specific robot that was doing this specific thing at this temperature. And so we can start doing it. You can train models, and you can do that without even data scientist, because all of a sudden you have all this correlated data, and you can do that. And that's where all this feature engineering and feature identification comes in, and why it's so critical. And a part of that process, of course, is the credentials and assigning kind of that trust zone, and that idea of when do you actually put the credentials in. Well, they go in at the minute that you know that that vehicle is going to roll off the line. But it's a very, very secured process too, and it has to be automated. Not anyone can just walk in and steal a bunch of certificates for a whole batch of vehicles, right? So that there has to be, physical security considerations, everything, because that is the weakest point in all of your IoT security, is that point at which all those certificates, all of those credentials get burned into that firmware. So there's a lot of consideration, a lot of physical security. That's always considered in that strategy. Typically, what you'll actually see is those are disconnected processes. So instead of there, it's actually communicated across to wherever the actual ECU is being made, and it's done in a separate facility, and then they're paired up, in a drop ship or something along that line, some part of the logistics line, so that there's never actually any co-located types of things that are going on. So you can kind of manage that process. So it's a lot harder to thwart that process and mess with your credentials if someone were to do it, because it is a very, very critical kind of thing, particularly as we're headed into autonomy. Autonomous vehicles and stuff. This is getting really important, because now, those credentials, those things are at any point, if those credentials are shared or whatever, compromised, you're screwed, because there's a lot of power that can be done with that autonomous vehicle. So it's all that kind of stuff that goes into the consideration, design, and architecture of where that stuff is. And just in our little detail here, they're different routes, because you're not authenticating, right? You're not posting data using that email and password anymore. You're posting data with those credentials that are then being checked against that vehicle database, and all those different things. So always think about that you're always actually have a couple of, in an IoT system, connected system, you always have a couple of different facets of security and authentication, and enforcement when you're talking about system design and everything. We usually split those routes up very specifically. And in many times, you're actually implementing those routes on a totally separate server, because you need better uptime, or you need more guaranteed kind of dedication and those types of things, better monitoring, different types of strategies. So actually split the user routes out into a different server completely than even your embedded routes. So these are all considerations that you go through when you're looking at architecting a system.
I have a question here. So you said that these credentials would be embedded the point the vehicle is manufactured, right? So would there be a feature, in order to change these credentials? Because what would happen if that owner sells this vehicle to somebody else? The first owner would still be having access to these
Right.
details, right?
Right. So, well, technically, if you think about how that flow is, the owner never actually has physical access to the actual certificates, or let's make it easy, a key and secret, because that's really what it ends up being. The cryptography and certificates is basically a detail implementation of how it's enforced. The So like a key and secret, those are never actually exposed to the user, because that's actually kind of an agreement between our cloud and the vehicle. And it's actually the fact that the user gets connected to the vehicle is actually done up in the cloud with a database record, specifically a link. So that user record will have a link to the vehicle record. So if someone sells their vehicle, then it gets sold, and as long as the processes are in place, you just remove that link between the vehicle table and that user table. At which point, that user cannot have access to that stuff anymore, and that authorization doesn't pass. You don't necessarily have to change credentials in the vehicle, because those were never exposed to the user, right? They might, and when we start talking about and thinking through features like, oh, can I unlock the car? Right now, we've only pulled data up from the vehicle, but we can also think about what are things that we can do to the vehicle from your phone, from your app. You can unlock the car, right? Well, if the route, the action route that says unlock the car does not pass your authorization because the user doesn't have a link to the vehicle, the fact that the vehicle credentials are the same doesn't matter because it's really more about what you've exposed credential wise from the user perspective as opposed to the vehicle. So always keep in mind that the relationship between the embedded system, the embedded domain, and the cloud domain is kind of a sacred one. You should never let the user get in the way of that. You should always treat the user and the client as kind of this side thing that you're just giving them temporary privilege to access this sacred type relationship between the embedded and the cloud domain. At any point, you can remove that in the cloud. Always architect that way because it makes life a lot easier. But that's a great point, Shweta. I mean, and you hear these horror stories of the Google Home, right? The Google Nest, right?
Mm-hmm.
For how great the Google engineers are, one thing they forgot to kind of think through was what if people move? So they put out all these nests, all these little thermostats, and people were able to see, once they moved, they were still able to get access, and there was no feature to allow them to deprovision. Or if there was a feature, it wasn't enforced, and those types of things. And people weren't educated in the way to make sure that this was understood. And so, like, it's these types of things that, as connected product architects, we have to continually think through and be aware of as we go. And we need to always think that 2 or 3 steps ahead to make sure that when we architect it, it's not going to be a huge tear up like, oh crap, I got to now change all these certificates in all of my 50 million vehicles that are on the road every time they get sold. So always think about how you architect to avoid that kind of really invasive sort of structural uprooting type of things that you might have to go through.
And
Those are good
speaking
points.
of linking users to vehicles, if you guys remember this table here on the screen, the user vehicle table, we actually added that to the provision route, right? Here's our post provision. And if you recall, we do an insert into that so that we know, and back when we set this up, we actually did require the token, right? So based on that token, we can figure out who the user is because it attaches a user record to the rec object when it comes in. And we haven't updated this vehicles route here, but really what we should do now that we have access to this, we shouldn't return all vehicles in that entire vehicle table anymore, right? And this can be a homework exercise. What we should do is we should gather all records in this user vehicle table corresponding to the user ID attached to that token, and then getting a list of all vehicles in this table that correspond to the vehicle IDs that we're linked to. And
Right.
so you can see how this data model is actually set up so that you can have multiple users in the system, and when each user logs in, that user only gets access to their batch of vehicles.
So ask about that if you're interested in that, and you still have questions. Ask about that in office hours, and we'll take you through because it's relatively straightforward how to do it. But it all comes down to this user vehicle link table. That is basically providing the privilege of the client to connect to that sacred kind of connection between the embedded domain and the cloud.
All right, so how much time we got?
Not 10 minutes.
10 minutes?
What else did you want to do?
I'm going to add a vehicle context. So we'll get a little bit of progress. Well, we got some stuff I think that is going to roll over into office hours, but we'll get the bulk of it in. So let's make ourselves a vehicle context, because what I'd like to do, right? We got our vehicles page. One thing that you notice every time we refresh this, it sends a full new request to the back end, right? You see that no vehicles found yet, and then it pulls them all down. We don't need that. We could be saving this into a vehicle context, loading it when it's ready, but getting a cache right there, you know, and having access to exactly all the vehicles that we've already pulled down. On top of it, we kind of want access to that vehicle data here even, right, on our homepage. So we can say, you know, you have 6 vehicles in your inventory, right? These are the makes that you have. These are the year ranges that you have of your vehicles, that kind of aggregate information of a snapshot. And the way we can do that is by setting up a vehicle context. So I'm going to copy and paste the user context. All right, replace user with vehicle here. And then if we look in vehicles, these are already the vehicle list and vehicle data. These are the pieces of state that we know that we need already, right? So I'll set this one here to vehicle list. This is going to be vehicle context, right? And vehicle list will be an empty array. And then the other thing we want is vehicle data. All right, and that default value is just an empty array. This is going to be our vehicle context, right? We save that. We want to save the vehicle list as well as vehicle data into our local storage. All right, we'll pass all these down. Vehicle list, vehicle data, as well as the setters. Right? So that's our provider. Same pattern that we've been using on the rest of the context, right? Except if we look back at the tree, we don't want to make the vehicle context available to everything. Really what we want is we want these private routes to have access to the vehicle context. So let's think about how we can actually add that real quick to the private routes. I'll come in here, right? So what we want is if this thing actually is authenticated, that's where we want to do that request to go ahead and get that vehicle data. So I'm going to make real quick what's called a higher order component. All right, and since we're just using that here, I'm going to make it just within this file. A lot of these higher order components are the conventions, they start with a word with. So I'll just say with vehicle data. We pass a component as an argument, and it itself returns a functional component. All right. Now this thing itself needs some information. We want to know if the thing is authenticated. All right. We also want a token, because this is where we're going to do that get vehicles request. So the other thing we need in addition to this is, instead of just the auth context, is we want the vehicle context. But we haven't set the vehicle provider yet, right? And that's what we're going to set here in a second. So let's just assume that with vehicle data, we have access to the vehicle provider. And remember, we can have a setter, which is set vehicle data. And we also want to be able to set the vehicle list. So we'll use context. Here's our vehicle context, right? And then we will use an effect in here. Now the effect that we want, we can actually borrow right here. This is what we're trying to capture, right? This use effect that gets mounted just on the vehicles. We want this to get mounted anytime we actually access a private route. So we need to import the API, right? We already have the token available. We can pass that in. Now the thing is for this use effect, where are we at here? We only want this to run once, right? But we actually don't even need to run this unless we're authenticated, remember? Because if we're not authenticated, then we don't have a good token. So we'll say if is authenticated. Remember, this is a private route, so if you make it past this, then you should be authenticated anyway. And then we actually want this thing not just to run once, but if is authenticated changes, that's when it'll run. And then what we do is we actually just return that component that got wrapped, and we pass the props through. Right, so that's essentially how you make you set up a higher order component. And then what we want to do down here is we're going to make something instead of just a route, we'll call it an enhanced route. And it's going to be with vehicle data route. So enhanced route actually returns with that vehicle context already loaded up. All right. So now what we should be able to do is we should be able to come in here, comment out this use effect. Since by the time this thing got mounted onto the DOM, it should have the vehicle data. And we're going to import our vehicle context. But wait a second. I haven't set up the provider yet, have I? So that's one of the things we're missing. So let's come back here to provider private route. So we need to set up the provider here. So let's go ahead and import that vehicle provider, since we didn't set it up in that typical tree, right? So here's your vehicle context provider. And then just like we did here on the app tree, where we've got our auth and our user context, we're setting up so that anything that gets passed into these private routes will also have that vehicle provider, right? And that's exactly how we scoped it. We don't want anything that's not authorized to have access to that vehicle context data, right? So all we need to do is, instead of just passing back this enhanced route, we'll put it inside of the vehicle context provider. Right? And now we know, because vehicles is inside of a private route, that it will have access to this vehicle context provider. Right, so now I have my vehicle context. I can use context here. And we'll grab vehicle list and set vehicle list. Instead of use state, it's use context. Vehicle context. Then it's actually all the same context. And if we look, set vehicle list doesn't actually get called anymore. So now when we run this guy, it should actually not take that long to load the vehicles back up. So we got user is not defined. Oh, okay. So this use effect needs to watch vehicle list and vehicle data. That's just a copy paste error. All right, so you look here, we've got our vehicles. We go to home, come back to vehicles. You see how much faster it loads? That's because it's already stored there in the context. Even if I refresh, it's going to pull it straight from local storage, right? Now, when it mounts, it is calling. It's going to refresh it if they change, but at least you have the last cast value, right? And not only that, we can now access this kind of data in home, right? So if I go back to home, I've got use context. I can actually bring the vehicle context in here now too. I'll say vehicle list, right, from our vehicle context. And I'll just say you have vehicle list length vehicles. There you go. You have 6 vehicles. So I know that was all pretty fast, but you guys see how you can use the context not only to provide information in a downward sense, but you can also set it up so that you can scope it for the individual elements so that you can go across, right? And so what we did is instead of when this particular vehicles component gets mounted, instead of just requesting for those vehicles the moment that gets mounted, we request it the moment that any of these private pages gets accessed. And they all, because they all can have things that are relevant to the vehicle data.
No reason to reload and do an additional HTTP call when you don't have to, right? It just slows your experience down and everything. So it's always good to kind of push that. And then if there's an update to the vehicle information or whatever in like a different, let's say an administrative dashboard or a service record or something, you can make an MQTT topic that would then notify to update, which at that point the front ends could then go and request new information. But it'd be totally asynchronous then, so you're not constantly moving traffic around. Data's expensive, particularly in a mobile sense, right? And we all know how expensive our cell phone bills are unnecessarily. I mean, it's no different for this type of stuff. So you want to minimize the amount of data transfer if you can. So there are strategies to mitigate that. So any questions? All right. Sweet. Nice work, JC.
Have a good night, guys.
All right. Thanks,
JC.
Yeah.
Thank you.
All right.
Thank you.
See you guys.
Bye.
Can you do a quick push for this to GitLab so I can take a look at the last part that you just did?
Yeah, I'll put this up in the weekly content. So you'll see it on that resources channel.
And Justin, if you want to get me that recording, I can add it.
Yep.
Cool. All right. See you guys.
Bye, guys.
Have a good one, guys.
Have a good one.
Thank you.